Hello everyone, so this is the next lecture in Maths in Physics video lecture series. So here I'm going to discuss the trigonometric ratios, the trigonometric identities, how to find out the sine, cosine, tangent, and how do you apply it in case of the physics numericals. So first of all, the very basic thing that these all concepts are only applied if you have a right angle triangle. The conditions are applied. We won't go into too much of the depth over here. So we have two right angle triangles, and let me call the name as ABC, and this is again ABC. I'm going to take this angle as theta1, and over here this angle I'm going to take as theta2. Now always understand that in case of the right angle triangle, if this is 90 degree, that is the highest angle out of all the three, then the length opposite to that is always going to be the longest, and we call that as hypotenuse. H, capital H. The side opposite to the largest angle is always going to be the longest. In this case, this is your hypotenuse. Now, the length which is below the angle and the hypotenuse, this I am going to call this as base. I am going to represent this as B. So base is always attached, it's a line of the triangle which is attached to the angle, right? So you may also say that between the hypotenuse and the base, the angle needs to be sandwiched, correct? Alright, so in this particular case, this is the angle, so the base and the hypotenuse always sandwiches the angle. So over here this becomes the base of the triangle. Now, the third side that is opposite to this angle is going to be referred as perpendicular, capital P. So this side is the perpendicular, capital P. Over here, exactly opposite to this angle is your perpendicular. So please note that there are three terminologies: perpendicular, base and hypotenuse. Let's revise very fast once again. The longest side of the triangle is always hypotenuse, it is opposite to the largest angle. The angle which is given over here, whose sine theta, cos theta and the tan theta that you are interested to find in, that theta should be sandwiched between the base and the hypotenuse. So here this is the base, here this is going to be the base, because base and hypotenuse sandwiches your angle, right? And the remaining third side becomes the perpendicular, that is opposite, just opposite to this angle, right? Okay, now there is a trick which is given over here, and I call this as a magic trick, right? This is Pandit Badri Prasad Har Bole. Now how do you need to remember it? Just write down Pandit Badri Prasad, then below it write down Har Bole. Just write like this, straight line. Okay. Alright, now like this, make three lines. P upon H is perpendicular, base upon hypotenuse, perpendicular upon base. So three things. Now first of all, sine theta. Sine of theta 1 over here, the first one P upon H is sine theta, the cosine theta is B upon H, and tan theta is P upon B. So sine of theta 1 is basically the ratio of two sides of the triangle. One is perpendicular, the another one is hypotenuse. So perpendicular upon hypotenuse. Perpendicular over here is AB divided by hypotenuse is AC. Correct? So this is how we define the identity. Now if I am asked to find out what is cos theta 1 is going to be base upon hypotenuse. So base is BC. This is base upon hypotenuse. So this is BC upon AC. Now the third one is, suppose if I am asked to find out the tan theta, right? So tan of theta 1 is equal to perpendicular upon base. So over here perpendicular is AB upon base is BC. You may also check that if you find out this divided by this, simply if you take the ratio of these two, you will see that the AC and AC gets cancelled, you will get this one. So tan theta can also be written as sine of theta 1 upon cos of theta 1. So basically sine theta or cos theta or tan theta are the ratio of two sides of the triangle. Alright, so now let's find out the value of sine theta 2, cos theta 2 and tan theta 2. Tan is basically a short form of tangent. This is sine and this is cosine, right? So we write down cos. Okay, so sine theta 2 is perpendicular upon hypotenuse. So perpendicular is this. So that is equal to BC upon hypotenuse is AC, correct? Cos theta 2 is base upon hypotenuse. So base is this. So that is AB upon hypotenuse is again AC. Alright, now perpendicular upon base. So perpendicular is BC upon base, that is AB, is the tan theta 2. Now you may very well check this. If you find out the ratio, then AC gets cancelled. You are anyhow going to get the same answer, because tan theta 2 is equal to sine theta 2 divided by cos of theta 2. Right, so this is how we may do it. Okay, now let's go ahead with small angles. So suppose if you are being given, suppose I will tell you how to remember it, right? I'll tell you how to remember this one. First of all, please make a table something like this, and then you have to write the angles. The angles will be asked in physics from till grade 10 will be 0 degree, then you may be given as 45 degree, 30 degree, 60 and 90. Only 4 to 5 angles you are supposed to remember, right? So I'm going to write down over here as sine of theta, then cos of theta, then tan of theta, and here I am going to write the angles like this. Okay, so the first angle that I am going to write down is 0 degree, then I am going to say 30 degrees, then I am going to write down 45 degree, then we will be having 60 degrees, and an additional column I will have to make it for 90 degrees. That's it. So these values are all very easy to remember. See what the trick is. The trick in case of the sine theta is you first of all write down 0, 1, 2, 3 and 4 in case of 90 degrees. These are all the angles, right? 0, 1, 2, 3, 4, and here you write down 4, 3, 2, 1 and 0. Now divide all numbers by 4. All numbers needs to be divided by 4, and then finally we are going to take the square root of all of them, and that will be your final answer. So now the last step is to take the root of all of them like this. Anyhow, this answer is going to be 0, because 0 divided by any number is 0. This is 4 by 4, that is 1, and under root of 1 is 1. If I take the under root, this answer is going to be 1 by 2. Under root of this is root 3 by 2, and this is under root of this is 1 by root 2, because 1 by 2 and then the square root, right? This is again 1 by root 2. Now over here, if I take the root, that will be under root of 3 divided by 2. This is 1 by 2. Under root of this is going to be 0. Under root of this is going to be 1. So easy, right? So first of all, write down 0, 1, 2, 3, 4. Here in the reverse sequence, 4, 3, 2, 1, 0. Divide all numbers by 4, take the roots, and you will get the answer. So for example, sine of 45 is 1 by root 2. Sine of 60 is root 3 by 2. Sine of 90 is 1. Sine of 0 is 0. Sine of 30 is half. In the same way, cos of 0 degree is 1. Cos of 30 degree is root 3 by 2. Cos 45 is 1 by root 2. Cos 60 is half. And cos of 90 degree is going to be 0. Now, as I said that if you divide these two numbers, so tan theta is sine theta. That is, if I want to find out tan 0, I'll have to find out sine 0. This divided by this. So 0 divided by 1 is going to be 0. Then this divided by this, if I find out, 2 will be getting cancelled, 1 by root 3. This divided by this number, I am going to get my answer as 1. This divided by this, I am going to get my answer as only root 3, because this 2 is going to get cancelled. Here 1 divided by 0 is infinite, right? So these are the value of tan theta. Tan 0 is 0, tan 30 is 1 by root 3, tan 45 1, tan 60 is root 3, and tan 90 is infinity. So these are the things that you need to remember in case of grade 9 and 10 numericals, and that was a short lecture on trigonometric identities.